Bismillahirrahmanirrahim, my dear students. Here is your mathematics teacher Muhammad Amjad Saeed from Pakistan International School, Taif, Saudi Arabia. And I hope that you are all okay. And last time we were having our lecture number 40. Today we will continue our lecture number 41 from the same exercise 9.2. Last time I left one question number 9. Actually, this question number 9 is to be solved now. The question is, show that the points M and P, Q are the vertices of parallelogram. First of all, we have to draw a rough sketch. This is M is minus 1, 4. Minus 1, 1, 2, 3, 4. M is minus 1 and 4. N is minus 5 and 3. Minus 1, minus 2, minus 3, minus 4 and minus 5, 1, 2 and 3. N is minus 5 and 3. P is 1 minus 3. P is 1 minus 3. 1 minus 3. And Q is 5 minus 2. 1, 2, 3, 4, 5 and minus 2. Q is 5 minus 2. We have to prove that these are the vertices of parallelogram. Definitely, I told you that whenever the four vertices are making a parallelogram, then opposite side will be equal in length. So it means that we have to prove that PQ is equal to NM and NP is equal to NQ. But remember, this is the diagonal. Opposite vertices are joined together, that is known as diagonal. The length of the diagonal will not be same in case of parallelogram. This is the difference between rectangle and a parallelogram. So here is Pn mod, Pn mod, first minus first whole square, second minus second whole square whole under root, minus 6 square and 3 plus 3 square under root, 36 plus 6 square again, 36 plus 36, that is 72 under root, 6 into 2 under root. This is Pn. After that, MQ or Qn. Qm mod. Qm. First minus first whole square plus second minus second whole square whole under root. Minus 6 square and 4 plus 2 square. This will be 6 square and plus 6 square, 36 plus 36, that is 72 under root, 6 into 2 under root. You can check that Pn is equal to Qn. Opposite sides are equal in length. Similarly, we can take PQ is equal to Nm. Here is PQ, distance between P and Q, PQ. First minus first whole square, 5 minus 1 whole square, plus second minus second whole square, whole under root. 4 square, minus 2 plus 3 square, 16 and plus 1 under root. Actually, this is 1 square is 1, 17 under root. This is PQ. Similarly, NM mod, first minus first whole square, second minus second whole square. Here is minus 1 plus 5 square. This is 1 square under root. 4 square plus 1 square. This is 16 plus 1, that is 17 under root. Dear students, you can check PQ and nm, they are equal in measurement. Similarly, Pn and Qn, they are equal. So, still to confirm that it is a parallelogram or a rectangle. Basically, this is the same condition for rectangle. Up to now, we do not know that is it a rectangle or a parallelogram. If the length of diagonals become equal, then it becomes a rectangle. If the length of diagonals are different, then it will not be a rectangle, it will be a parallelogram. Here we can check. What is the diagonal? Pm mod. This is diagonal Pm mod. First minus first, whole square. Second minus second, whole square, whole under. Minus 2 square and minus 7 square, whole under. 4 plus 49, that will be 53 under root. After that, this will be Qn. Qn mod. Qn mod is minus 5 whole square. Then 3 minus into minus 2 whole square, whole under root. Minus 10 square, and here is 3 plus 2, 5 square. Here is 100 plus 25, that will be 125 under root. Dear students, you can check Pm mod was 53 under root and Qn was 125 under root. Now we conclude our answer. Here we have conclusion now. As Pn mod is equal to Qn mod, PQ mod is equal to Nm mod, but diagonal Pm mod is not equal to diagonal Qn mod. Therefore, PQMN is a parallelogram. This is your conclusion. PQMN is a parallelogram. I hope that you got that right. After that, we have next exercise. Before we start our next exercise, dear students, before we start our next exercise, we have to discuss a formula that is known as midpoint formula. Distance formula will be applicable over there also. But we have another formula that is known as midpoint formula. Midpoint formula. Dear students, look at that. If, for example, we have A of x1, y1, B of x2, y2, and C is a point or P is a point of xy. If P is a point between AB, P of xy be a point between AB such that P of xy is the midpoint of AB, then x will be equal to first plus first over 2, second will be equal to second plus second over 2. So it means that your midpoint is actually P of xy is equal to P of x1 plus x2 over 2, y1 plus y2 over 2. It's very easy to remember. If P of xy is a midpoint, then value of x will be first plus first over 2. Value of second is second point plus second over 2. That is your formula. In exercise 9.3, we have Question number 1, part BDE, part BDE. Then question number 2, 3 and 6. Question number 2, 3 and 6. These are the questions in your exercise 9.3. Question number 1. Find the midpoint of the line segment joining the pair of points. That is, B is equal to A of 2 minus 6 and B of 3 minus 6. What is the midpoint? Midpoint of AB. First plus first over 2. Second plus second over 2. Here is 3 plus 2 over 2. Minus 6 over 2. That is 5 over 2. This is minus 12 over 2 is minus 6. Dear students, this is your answer. This is the midpoint. Similarly, in case of D, you have point minus 4 and 9, and B is minus 4 minus 3. What is the midpoint of AB? Midpoint is equal to first plus first over 2, second plus second over 2, plus B plus minus minus actually. Minus 8 over 2 and 6 over 2. That is minus 4 and 3. That's your answer. Similarly, in case of part E, you are given A of 3 minus 11, B of 3 and minus 4. What will be the midpoint? Midpoint is first plus first over 2 and second plus second over 2. 6 over 2 and minus 15 over 2. You can say this is 3 and minus 7.5. Dear students, these was the question number 1, part BDE. After that, we have question number 2. In case of question number 2, actually we have to find a point, unknown point. The end point P of a line segment PQ, this is P and Q. The end point of PQ, end point PQ of line segment PQ is minus 3 and 6, and midpoint is, suppose it is R, midpoint is minus 3, 6. Find, no, this is not minus 3, 6. Actually, it is 5, 8. Find the coordinate of point Q. Suppose coordinate of point Q are AB. Coordinates of point Q are AB. Actually, we have to find Q of AB. So, according to formula, if this is a midpoint, this is, suppose this is x1 and that was y1. Here was x and y. Here was x2 and y2. By definition of midpoint formula, you can check x first is equal to first plus first over 2, second is equal to second plus second over 2. That was the formula. So first x is equal to x1 plus x2 over 2, y is equal to y1 plus y2 over 2. Put the value of x. What is the value of x? 5. What is the value of x1? Minus 3. And what is the value of x2? A over 2. Then value of y is 8. Y1 is 6. Value of y2 is b over 2. Bring this 2 here. It is 10 is equal to minus 3 plus a. Here will be 16 is equal to 6 plus b. B is equal to 16 minus 6. A is equal to 10 plus 3. So A is equal to 13, B is equal to 10. Therefore, required point Q of AB is equal to Q of 13, 10. This is your answer. Dear students, that's your answer. After that, we have question number 3. Question number 3. Prove that the midpoints of hypotenuse of a right triangle is equidistant from the three vertices PQR. Question number 3. Dear students, first of all, you will draw a rough sketch. You will draw a rough sketch. Question number 3. Prove that the midpoint of hypotenuse of right triangle is equidistant from its three vertices. P is minus 2, 5. Q is 1 and 3. And R is minus 1, 0. Minus 2, 5, 1, 3. And minus 1, 0. Now you will draw a rough sketch like this. Here is minus 2 and 5. Minus 1, minus 2. 1, 2, 3, 4, 5. Up. This is B. Minus 2 and 5. After that, Q is 1 and 3. This is 1, 1, 2, and 3. Q is 1, 3. Then R is minus 1, 0. Here is R minus 1, 0. Join them. But remember that this is 90 degree. The question is, midpoint of hypotenuse is equidistant from the endpoints. It means that, for example, if I take this point as A, which is the midpoint of PR, then we have to prove that AP is equal to AR is equal to AQ. We have to prove this. The question was, find the midpoint of hypotenuse. Midpoint of hypotenuse of right angle triangle is equidistant. Equidistant means as at equal distance. Is at equal distance from corners, from vertices, from P and from Q and from R. Let A is equal to midpoint of PR. What is midpoint of PR? First plus first over 2. Midpoint. First plus first over 2. And second plus second over 2. This is minus 3 over 2 and 5 over 2. You can say minus 1.5 and 2.5. Here is minus 1.5 and 2.5. This is the midpoint of hypotenuse of right triangle. We have to prove that PA mod is equal to QA mod is equal to RA mod. Distance of A from all vertices are equal. What about PA mod? First minus first whole square minus 1.5 minus into minus 2 whole square and 2.5 minus 5 whole square whole under root. That will be equal to QA mod. First minus first whole square, second minus second whole square whole under root. is equal to RA mod minus 1.5 minus into minus 1 whole square plus 2.5 minus 0 whole square over under root. Dear students, you can check. Here is minus 1.5 plus 2 whole square, and this will be minus 2.5 whole square is equal to minus 2.5 whole square and minus 0.5 whole square. Here is minus 1.5 plus 1 whole square and 2.5 square whole under root. 2 minus 1.5 is 0.5 square and 2.5 square. Remember that this square will make it positive, and this square also makes it positive. 0.5 square whole under root is equal to minus 0.5 square and 2.5 whole square whole under root. Dear students, 0.5 is 0.25 square. 2.5 square will be 6.25. Here is 6.25 and 0.25. Minus 0.5 square will be 0.25 and 6.25. Here will be 6.5 under root, 6.5 under root, and 6.5 under root. This is verified. Okay, this is finished. Equal. After that, we have question number 6. Question number 6 is, the vertices of triangle are this and that. Show that the length of line segment joining the midpoints of the line segment PR QR is half PQ. Basically, this is actually the vertices form of your theorem. The line segment joining the midpoints of two sides is parallel to third side and half of it in length. Half of it in length. This part is your part of your theorem. First of all, we will draw the rough sketch of this figure. P is 4 and 6. This is origin 1, 2, 3, 4. 1, 2, 3, 4, 5 and 6. P is 4 and 6. Yes. Next is Q and minus 2, minus 4. Minus 2, minus 4. 1, 2, 3 and 4. Q is minus 2 and minus 4. R is minus 8 and 2. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8 and 2. R is minus 8 and 2. We will join them to make the triangle. This is your rough sketch of triangle PQR. What is given? Show that the length of the line segment joining the midpoints of line segment PR. Midpoint of PR. Suppose it is A. Then midpoint of QR. This is QR. This will be midpoint of QR. Midpoint of QR. That will be midpoint. Suppose it is B. We have to join it. The length of AB will be half of PQ. This is your question. Line segment joining the midpoints of two sides is equal to half of PQ. That is given. Let A is equal to midpoint of PR. What is that midpoint of PR? First plus first over 2. second plus second over 2. That will be minus 4 over 2 and 8 over 2. That is minus 2 and 4. A is minus 2 and 4. This is the midpoint of PR. First plus first over 2, second plus second over 2. Similarly, B is equal to midpoint of QR. That will be equal to first plus first over 2 and second plus second over 2. What will be that? Minus 10 over 2 and minus 2 over 2. That will be minus 5 and minus 1. Here is minus 5 and minus 1. Dear students, the coordinate of B is minus 5, minus 1. This is origin 1, 2, 3, 4 and 5, and this is minus 1 down. So approximately we have drawn that. Here is, we have to prove that AB mod is equal to half of PQ. This was the question. Show that the line segment, length of the line segment joining the midpoint of these two sides will be equal to half of PQ. We have to prove that AB mod is equal to half of PQ. What about AB mod? First minus first whole square plus second minus second whole square whole under root. Then 1 over 2 PQ mod first minus first whole square minus 2 minus 4 whole square minus 4 minus 6 whole square whole under root. That will be minus 5 plus 2 square minus 5 square whole under root 1 over 2 minus 6 square minus 10 square whole under root 1 over 2 into 36 plus 100. Here is minus 3 square and minus 5 square under root. 9 plus 25 under root is equal to 1 over 2 into 136 under root. Here is 34 under root is equal to 1 over 2. Actually 136 will be 2 into 34 under root. 2 cancelled out. So 34 under root is equal to 34 under root. Left hand side is equal to right hand side. Verified. So we have verified answer. That is your answer. After that, dear students, this chapter, this 9.3 exercise finished. We have review exercise, choose the correct option. In first is distance between 0, 0 and 1, 1. Apply the distance formula. Your correct option is D, that is 2 under root. Part number 2, distance between 1, 0 and 0, 1 is again 2 under root. This is C option is correct. Apply the distance formula. Part number 3, midpoint of 2, 2 and 0, 0 is first plus first over 2, second plus second over 2, that is 1, 1. Apply midpoint formula, that is A option is correct. Fourth part is midpoint of 2 minus 2 minus 2, 2. When you add them by midpoint formula and divide by 2, that will be 0, 0, that is C option is correct. Part number 5, a triangle having all sides equal, that is equilateral triangle, that is C option, correct. Sixth part, triangle having all sides different, that is scalene triangle, your B option is correct. After that, you have question number 2, answer the following, true and false. A line has 2 endpoints, no, it is wrong. This is the line. Line has no endpoint. Even line segment has 2 endpoints. Segment means part. Line segment has 1 endpoint, it is false. It has 2 endpoints. Triangle formed by 3 collinear points. No, collinear points are on the same straight line. How can they make the triangle? Actually, 3 non-collinear points make the triangle. Like this. Each side of triangle has two collinear vertices. Yes, correct. Each side of triangle two collinear vertices. These are the two collinear vertices. These are the two collinear vertices. Similarly, the endpoints of each side of rectangle are collinear. Yes, it is correct. All the points that lie on x-axis are collinear. Yes, it is correct. On x-axis, all the points lie on this one. Origin is the only point collinear with the points of both axes separately. Basically, look, this is x-axis and y-axis. This origin is the common point between x-axis and y-axis. This is the only common point between the points of x-axis and y-axis. All other points are different from that. Okay, so that was finished. So your chapter number 9 is finished. Inshallah, after that we will start our next chapter. Hopefully, inshallah, we will finish our practical geometry exercises 17.1 and 2 first, and then we will come to the different questions and theorems of your previous chapters. Already we have finished up to 13 chapter theorems. So we have to start from 14, 15, 16, and inshallah we will do all those things which are given in the review syllabus, and inshallah we will do it as early as possible so that you can have more time for revision. So inshallah, okay. Allah Hafiz and Assalamu alaikum wa rahmatullah.